completely forgot to put a link to this hangout on CosmoQuest.org. So I'm going to fall into happy programmer land here and edit the site live. I should be wearing my shirt that says, I don't always test my code, but when I do, it's in production, because that's what I'm about to do.
Oh, boy.
And we are going to have Stuart and Irene on, if we can get them in from the green room now.
So Timothy in the green room, if you can send Stuart and Irene our way, same link as before. I will also send them. I think I can send them. There they are. There's one. And while I'm doing that, thank you, Richard. Two quick things. One of them is, yes, we have Little Will Wheaton here from Hijinks Ensue. It's a webcomic that, you know, geeky and fun that I like. And so not CosmoQuest related at all, but go check out Hijinks Ensue. It's a fun webcomic, and you can get your own little Will Wheaton plushie. And I forgot what the second thing was. I'm sure it'll come to me at some point. So we're monitoring all the Twitters and things. So up next, we do have Stuart and Irene coming from the Moon Mappers team, as long as Tim got my message. Where is he?
So the way things are running today, for those of you who want to see what's going on behind the scenes, or at least hear what's going on behind the scenes, I'm apparently going to mix the word scene here randomly throughout these 32 hours. The two of us are currently running our own production. We will be switching that off throughout the event. This means that our computer is currently running the show, and Richard Drum is going to be helping out with that in the background for other groups of 4 hours. Every 4 hours, we do have to restart this event. We will continue to embed the link in the main event page on Google+. And then we also have various parts that people have signed up for, and as always, the cosmoquest.org/hangouts page will be playing what's going on. To help get our guests all set to come in, we have a green room hangout set up in the background so that the guests can go in, do a tech check, ask any questions they might have, and the green room is going to be run by a whole variety of people throughout the hangout, volunteers.
Ray, Tim, and Michael.
Yeah.
So those are our green room people. So Michael Forrester from Astronomy FM, Timothy Legauer, my boyfriend who's been roped into this by proximity, and Ray Sanders, who's one of our CosmoQuest instructors. So.
And so this entire event is really being made possible by the support of not just our significant others who did get roped into things, but also through a bunch of volunteers who are putting a lot of hard work into making this weekend possible. And Steve, thank you for the coffee. I'm about to go pour myself another cup. My husband just brought up a fresh pot for us. Ooh. And I love the fact that he tasted it and felt the need to find a thing of masking tape and put a giant label on the pot, which I'll show you all in a few minutes, that says strong. So apparently the coffee is strong. He then went back down the stairs and brought up creamer. So I'm going to go back to editing the website and welcome Stuart Robbins and Irene Antonenko, the co-leads for science for Moon Mappers. So welcome.
Thank you.
Thank you.
Hi. All right, so why don't you just start off introducing yourselves, tell us a little bit about your background, and what are your research goals with Moon Mappers?
Ladies first.
Oh, okay, thank you. Okay, my background, I am a lunar geologist. I've been studying the moon ever since I went to grad school, and I have learned so much about the moon in so many different ways. I'm always amazed when people ask me questions how much I can tell them. It's like, wow, I didn't know I knew that much. So I've been just really excited by how much I've learned. So what I do on the moon is I study something called cryptomare deposits. When you look up at the moon, you see white areas and black areas. And the white areas are the old crust, and the black areas are more recent volcanic deposits called Maria. Oh, thank you, Stuart. Lovely. So what we originally thought is that was that simple. You had a big crust, white, bright crust. Oh, that's beautiful. Thank you very much.
Sort of shows up.
Yeah, I think you've got Mare Oriental up there, right?
Yeah.
So you had a big, bright white crust, and then you had big impactors hit it and make these huge impact basins that are just basically huge bowls in the white crust, and then black lava, well actually it's not black when it flows, but it's lava flowed out and filled up these holes sometime later, and they solidified to become black basalts, and that's why you have this dichotomy of very bright crust and black lavas. And we originally thought that that's how simple the moon was, but now we're finding out that it's much more complex. And what happens is sometimes when you get a huge impact that happens after a mare was formed, you can get, if it has impacts into the highlands, it splashes effectively lots of bright highland material on top of the dark maria, effectively hiding it, making it a crypto-maria. So what I do is I look for these crypto-maria deposits, and that's one of the things that I want to do with moon mappers, is see how well I can find that. Now with moon mappers, we're looking at relatively small craters, so I'm going to be looking at the fine details, not the big scale, like huge Maria deposits that have been lost, but little thin deposits of lava that have been interleaved between highland layers. So that's what I'm looking for, and some other things as well, but that's a good place to start. So have I covered enough, Stuart? Is that good for me? Anything else you want to know about me? I guess a little bit more personal details. I'm married, 2 kids. If we had been here 15 minutes earlier, you would have seen one of them hanging over my shoulder, looking at himself in the display. But they're now headed off to the neighborhood street party 1 street over. So hopefully they'll be out of my hair for the hour. Otherwise, you get to meet them. There you go. Some science and some personal stuff.
Awesome.
On to you, Stuart.
Okay, so I let's see, what do I do? I've been studying craters for about 7 years or so. So I'm a recent doctorate. I pretty much just entered graduate school thinking I want to do planetary something, and then the first project that I did was studying some Mercury craters, and since then it's just sort of like, oh, well, I don't hate studying craters, so let's see if this is something I want to do. And it turns out that's what I did. So for my thesis project, I actually mapped out about 640,000 craters on Mars, all by hand. And I don't know if you can... So I have a giant callus right here on my finger because I have a pen and tablet input device, and so I would literally be drawing circles over and over and over again over 600,000 times. And so I've been using my Mars crater database to study a lot of things like how old some of the really big craters are, when things like valley networks were active on the planet. So Mars is not hugely dissimilar to Earth compared with all of the rest of the planets, and so we actually have these giant river valleys, and we want to know when those were active, because the idea is follow the water and we might find life or evidence for life, or as far as we know, life needs something like a solvent, like a medium, and water's a very good one. And so the idea is if we find evidence of water, then we're much more likely to find evidence for life. So when water was flowing on Mars is an important question. And so you can use craters to figure out when stuff happened, because the basic idea of crater dating, and this is probably one of the biggest uses out there for craters, is that the more craters there are on a surface, the older it is, because it's been there longer to accumulate those craters. Now you can do a lot of math and statistics and calibrate them with lunar samples that we returned from Apollo and the Soviet lunar craft, and actually calibrate this crater density. One crater density corresponds to a given age, another crater density corresponds to another age. And so that's really been the focus of my research over the past few years. And that's sort of something that I'd like to use Moon Mappers data to do, is to get a better handle on when some different stuff formed on the moon. Another thing that I'm interested in is sort of the statistics of craters. And this is actually something that we just submitted to a journal yesterday. Gets to this broader idea of how well do we actually understand how we use craters. So if I circle, say, 600,000 craters on Mars, if someone else were to try to spend 5 years of their life and do the same thing, would they come up with the same answer? And the assumption in a lot of research is yes, they would. But what we're actually finding is no, we wouldn't. And with thousands or tens of thousands of volunteers identifying craters on the Moon and on Mercury and on Vesta with CosmoQuest projects, we can start to get a better handle on those kinds of, well, what is the likelihood that we actually will find a crater of this type versus the likelihood that someone is going to miss it? And this gets back to all of those uses for craters, including how we use them for ages. So if I find a certain crater density on one surface, but someone else finds a certain crater density on that surface, then that could change when water flowed on Mars by 200 million years, which changes a lot of things. And in fact, in this paper that we just submitted yesterday, it's not 200 million years. This could change when we think water flowed on Mars by 1 billion years, based on the differences in one person identifying craters versus another.
Now, before you guys launch into the paper, and this paper, it was what, 11 authors and how many words?
11 authors, 19,540 words, something like 1,500 lines. It's one of my second longest paper. Very long.
So yeah, it's kind of awesome and crazy. When I first met you, it was at an Astronomy Cast hangout in Boulder, Colorado, and you basically had this look of, please, dear God, don't make me mark this many craters again. Can I please get involved in your citizen science? You didn't say that, but that was the look on your face.
I figured you were just going to put me out of business.
No, I decided to suck you in instead. So I'm listening to the answers. I'm getting requests to make changes to the website, so I'm going to actually work on embedding the YouTube for this video live on the front page of CosmoQuest. So, yeah, can you explain what it was like for you to be able to make the transition from having to mark everything and destroy your finger to being able to herd amateur astronomers doing awesome work online?
My finger feels better.
You still need it for typing all those lines in the paper.
Yeah, well, it's more the wrist action, because you're circling, but the pen is resting on the finger, so it's the whole hand area. No, it's been nice and it's been interesting. I mean, the issue is that with so many people, with people who aren't crater experts, we actually have to do not, like, one person, one crater. We actually have to get, we want to get at least 15 people or so identifying craters in every single image, that we can build up those statistics and say, all right, this is more likely to be a crater than this. And so it's a lot more stuff that has to be done, but it's also a lot easier on my hand. I'm not quite sure what else you were asking. As in...
So, for instance, I'm thinking about the laser grant we wrote, where we were able to essentially write that instead of asking for 8 months' salary for each of the two of you, so that you could just draw circles, we could ask the world to help us mark craters, find boulders, find all of the geologic features that could be interesting, have them do it for 8 months, and then you could focus your time on doing science. And this essentially created a huge savings to what we were able to produce for the amount of dollars that we were asking for.
Right. So normally in a grant, you are going to spend most of your, well, normally in any research project, you're going to spend most of your time gathering data. It is the boring part of science that no one ever tells you about, because they want to see all of the nice, cool results, which is maybe the last 5 to 10%. So in any proposal, you have to say, you need to fund me, or I want funding to spend 3 years of my time and maybe a graduate student's time and maybe 3 undergraduate students' time gathering all of these data, and then we're going to have this really cool result at the end. With this project, with CosmoQuest and with Moon Mappers, we were able to say, okay, we have statistics for how many craters people can find in a month, in a year, because we've been up and running for about a year and 3 or 4 months or so. Yeah. And with that data, we can then say, all right, instead of you funding me to identify craters on all of these different surfaces on the moon, instead of paying Irene to also do it, and instead of paying for me to have a graduate student or 4 undergraduates help do this, we can say, instead, you only have to pay me 2 months a year to do, to maintain the stuff, to put in new images, to gather new data, or not gather the data, but to analyze the data, and then do the science at the end. You only have to pay me and Irene maybe 2 months or so salary. You don't have to pay any graduate students. You don't have to pay any undergraduate students. And all of the data is going to be gathered by volunteers. And they're doing it because they're interested in helping gather data for science, to do real science. And because of that, the grant is so much cheaper to the funding agency. And I've been now on, 2 grant review panels, so it's not much, for the big scheme of things. But on the 2 panels I've been on, while cost isn't supposed to be a factor, it is something that we vote on. Like, are the costs reasonable? And it's something where we can also say, okay, the average grant for this program is maybe $100,000 a year. If this other proposal is only $30,000 a year or $40,000 a year, and it's only 2 years, so the total cost of this grant that we put in is something like maybe $80,000 to $100,000 for us for 2 years. That's less than half of the average cost of a grant to this program. And that's where the panel can go up to the program officer and say, look, we think that they're going to do neat science. Now, maybe it didn't rank quite as high in interest as this other thing that's going to reinvent the theory of gravity, but it's neat. And if you have a little bit of a corner pocket money, because it's so much cheaper, you should fund this project. And that's something that CosmoQuest allows us to do, is we can put in time for grants that are so much cheaper than other grants because it's the volunteers that are doing the data gathering process, and we don't have to spend 12 months of salary or 24 months, or if you have 5 undergraduate students for 2 years, then what is that, 120 months salary plus benefits plus tuition on gathering that data. It's done for free because if you spend, say, an hour a day watching television, then that's something that you can have your computer next to you and also be identifying craters. I mean, I've been telling my mom, look, you watch an hour of Judge Judy and 2 hours of soap operas at least 3 or 4 times a week. If you spent those 15 hours identifying craters, I could get a lot more papers out. And you
at the same time, it's not instead of TV, it's at the same time.
Right. I mean, when I circle craters on the moon, on Mars, or whatever, I have 2 computer screens up. I have one computer screen that has all the maps and all the data going on, and then I have another computer screen next to me, and the latest thing that I've been on is Law & Order SVU. After that, it's going to be Law & Order. And it's not something that you have to watch and has pretty graphics. It's, you can look over it every now and then, but I'm still doing work while I'm doing it. And identifying craters, especially with the very basic interface that CosmoQuest allows, you can do a lot of science at the same time. And that's something that we're asking people to help do, is even, every little bit helps, as they say, and that's really the case. Like, if you do one image, that's 15 more craters that we have to work with. If 100 people do 1 or 2 images, that's what we're getting up to 300 more craters. If you're in, say, a class, if you're in a schoolroom and you have an average of 25 students, if they do 1 image or 2 images or 3 images as an exercise to learn a little bit more about what's going on the moon or Mercury or Vesta as a school project, we have 1,000 more craters that we can work with. And it really builds up, and then we can go to these funding agencies and say, look, all you have to do is pay us to do the science, and other people are doing the work for us. You don't have to pay us to do the data gathering process. And I think I've repeated myself like 3 or 4 times now. So let someone else talk.
It's a very important point. You're getting more science per buck, and you're allowing people who otherwise couldn't be involved in scientific research to actually take part in that data collection process and take part in the real science. You're not just doing a pre-canned laboratory experiment, especially for students, as you mentioned, in school. One of the features that's coming with the new site is the ability to have groups, and so teachers can check in on their students and see how many craters their students have been marking. So, you know, here's an extra credit opportunity for you guys. So yeah, so it's an important point, getting the more science per buck and getting more people involved that otherwise couldn't or wouldn't be able to.
Yeah, Irene, do you have anything to add that I missed?
Well, I think one of the things that, I mean, while we're talking about funding, I think we really need to remember that, yes, it's free in terms of the volunteers, but there's also the server costs that we need to be able to maintain, and the programmers to keep the CosmoQuest sites up and running, and not just running, but running optimally. And I think we've done a lot of new updates that have come out relatively recently that have totally been amazing in terms of improving the user experience. And so that costs money. So it's not completely free. There is a cost associated, and I think we need to remember that, because that's one of the reasons I think we're here for this 24-hour-thon. Is this is the kind of thing that we're trying to collect money from, gather, what's it called, fundraise money for, is so that we can have the servers, so that and the programs, so the volunteers have the best user experience possible. So I think that's a really important point as well.
So CosmoQuest is made up of a whole community of people all playing different roles. We have our forum moderators, who are all volunteers who help hold the community together. We have our team scientists like Stuart and Irene, Brittany Schmidt working on the Dawn mission, Jen Scully also on Dawn. I can't even remember all their names at this point. Clark Chapman. And then we also have our core team of programmers, which is currently just Corey and Joe. And then I also program. I just finished changing our homepage and adding watch links to the entire site.
We're going to change the link soon.
That's
so.
okay. I wrote it so that
Okay,
it's easy to
do
change. The funding that we're seeking this weekend is the funding that keeps the core attributes of CosmoQuest going. The programmer salaries, part of my salary, Nicole's salary is needed, and then our educators. And this allows us to get school kids, just like Stuart and Irene were talking about, out there doing science. It allows us to keep the science going optimally, to build extra features. Over the past 16 months, working with Stuart and Irene, we've gone from having a good idea of what needed to happen to having a whole suite of scientist tools. And one of the things that I really loved reading through the monstrous paper that is submitted now was they found that when they had the 8 professional researchers using all of their normal native professional buku bucks software in many cases, if you averaged together all of their results and then, or medianed together, I don't remember which statistic it was at this point, and then compared that with what was coming out of Moon Mappers aligned with the dispersion on the other one in terms of it was just dead in the middle. And that was kind of awesome. We built a tool the scientists can use that is as accurate as the expensive software they might have downloaded in the past.
Yeah, and Irene, I think that you liked the CosmoQuest interface the best out of the 3 that you used. Is that, or you found it easiest, or something?
I found it easiest to use, that's for sure. I'm not sure that I would say best. I certainly wouldn't say not the best, but best is a loaded word, so I'm going to shy away from best, scramble away from best. But I did like it. I found it very easy and intuitive to use. In some respects, it was a lot easier than ArcGIS, I found. ArcGIS requires you to jump through a lot of hoops, and you're not using a native ArcGIS package add-on. You're using a third-party add-on, and so they sometimes don't play as well together as they should. And so there was a lot of headache associated with that. Constantly checking that you press the right button before the first button after the second button, and it didn't clear before you hit the 5th button, and yeah. So with Moon Mappers, there was none of that, and I found it extremely intuitive and easy. The JMARS, which is the other package that I use, has a very similar tool in that you just drag and click to increase the size of a circle so you can map the crater. And that was easy, but again, Moon Mappers was specifically designed to do exactly what we were doing when we were doing this task, that it just blew the other ones away because it was designed specifically for this task. So I enjoyed that very much. Yeah, I really found it intuitive and natural to use. Could it be improved? Sure, everything can be improved. I can always find ways to improve something.
And this is why we need to keep paying our programmers so that they can keep improving.
We have a question from Matt Schultz. If we get to the fundraising goal, how long will that let you keep the doors open, so to speak? And so that's the six months worth, which gives us time to write more grants with the changing funding situation that's happening on the federal level.
So to explain what happened, the grant calls that we normally go after went away. Either they evaporated into thin air due to sequestration, funding programs through missions were asked to cut back their funding pending the president's budget going through, or it was a case of until we have a federal budget, NASA couldn't put out the call for proposals. And so all of these various places that we would normally go to and figure we'd get about a third of the money that we asked for, all went away pretty much simultaneously. And if the president's budget goes through as written, all the money we rely on that we already have goes away as well. And so we're quite literally looking at, if the president's budget goes through, we go from fully funded to zero funding overnight. Right now we're looking at going from fully funded to Nicole's salary is fully paid, 20% of my salary is paid, and parts of our educator's salary is paid, but we lose Joe and Corey.
If we lose them, we're in a lot of trouble.
Yeah, and so I'd like to say that I'm worth more than 1 day a week. It's a scary place to be. I have my programmers asking me on a daily basis, how does it look? And I can't answer that, but you can answer that. You can say what we're doing to produce new science, to produce new educational tools is worth it by donating and by sharing the link and helping to get as many people as possible doing science, contributing to science, and learning science. That's what we're all about. So we're here trying to save ourselves from cuts that came out of nowhere, and I estimate it will take us 6 months to find alternative funding sources. And so we're asking for that 6 months of funding, and if we surpass our goal, then we know that there's people getting laid off from other institutions. I've heard of rumors of layoffs already happening at several well-regarded major institutions you'd think had full funding. If we have enough funding to save ourselves, we're going to start saving those people and contracting them to do the awesome things they've been doing for NASA under the umbrella of CosmoQuest. Now, I know the real question people have isn't what's happened to our funding, but what's happened to the science with Moon Mappers. And I'd love to hear you guys discuss some of the science results that you have preliminary, still being worked on, not yet published. So if you can share the stuff that's coming up in future publications, we'd love to hear it.
I'll let Irene go first.
Well, I was going to hope that we could get the graphic that we sent to Pamela earlier, the one with, because before we get into that, I think we need to address a question that we have been working really hard to address here, and this is what our paper that we just submitted is about. One of the things that we have found with citizen science data is there's quite the pushback from the community in using this kind of data. A lot of people are very hesitant to trust it because they firmly believe that experts must be so much better than volunteers. And if you get a bunch of volunteers together, they're just going to do a hack job and it's just going to be horrible, horrible, and why on earth would you ever want to look at that data anyway? So this is the feedback that we've been getting from the community in our field, and so this is why we did this paper, in order to show that not only are the experts not in agreement, as everyone seems to think, but also that our volunteers are doing a really banged-up job in terms of producing results that are similar to the experts. So we're looking at, this is a good place to be, I guess, we're looking at oh, okay, we've lost our image. But we've got this huge section that we had 8 experts look at in a variety of different ways.
Got it. Okay.
And once that comes up, you will see that there are everybody's marked craters. Okay. And we have our expert craters on one part, and we have our volunteer craters on the other part. And I'm not seeing the picture. Is it coming up?
So
yes,
I put it up as a
the audience can see it.
Yeah.
Okay. So now can they see the whole
Unshare,
thing? Because
Stuart.
I can only just see a small segment.
Yeah, she can only see that bit. She must see the whole thing.
I
Yeah,
put it up
screen
as a
up.
screen share. If you could put my screen up, does that work? I've sort of zoomed in on...
Which one do you want?
Can I have Stuart's for just a minute, and then I would like to have the one that you have, please.
Okay.
We have Stuart's up now. You can't see it, but the audience can.
Fair enough. Okay. So on the top, we have what the experts marked, and I'm not sure how well you can see that. Where I am, I've got a tiny thumbnail, so I
You
can't see
can
very
click
much.
on it to make it larger for yourself.
Oh, thank you. And there we go. Oops, there we go. So on the top, so I'm assuming you're seeing what I'm seeing. On the top, you can see the experts, and there's a different color for each expert. You can see that we pretty much line up quite well. It's actually pretty spectacular on how well we agree. And then at the bottom, you've got the volunteers, and all the volunteers are red. So you can see lots of different red and very thick-looking lines because the volunteers are not as good at clustering together as the experts are. Well, that's what we're getting from the community. They're saying, oh, look at how terrible it is. It's like they're not very good at all. The upshot of it is that, yes, each individual volunteer may not be good as any individual expert, but when you group all the results together, and on the bottom you'll see the white lines are the ones that represent the groups of what we did when we took all the volunteers together and figured out, okay, here's what the average is of the volunteers' results. You'll see that their average results are very close to the expert average results. So in fact, and now if you can zoom into when you had the top part, we can look at that even a bit better. When you had just the top right corner.
Hold on. Working on it.
Okay, waiting, standing by.
Oh, that did not behave as anticipated. Sorry.
Okay, top right corner, please, of the ones where you see 4, you can see 4 in one shot. Yes, there. Perfect, perfect. So here again we have some examples of the differences between what the experts are seeing on the right of the 2 panels of side-by-side craters and what the volunteers, or oops, did I say that wrong? The experts are seeing on the left and what the volunteers are seeing on the right. And so you can see the experts are nicely clustered, but the volunteers are sort of all over the place. But that white line in the volunteers is really well correlated with the white line in the experts. The white line in the experts also represents our average. So I think this is excellent. Now the one at the very top, I'm going to ask you to do some work for me again in a minute. The one at the very top is for very new craters, they're very pristine and crisp and haven't been degraded or eroded at all. But if we scroll down to the bottom of that image, we start to get to more eroded craters that are not as crisp and not as clean. And you can see that it starts to get, in fact, somebody might be looking at that bottom image and saying, there's a crater there? But yes, there is in fact a crater there. And you will see that the experts here are starting to diverge quite a bit too. You've got, a yellow circle that looks nothing like the pink circle and looks nothing like the blue circle. So like we're starting to get off too, because it is very hard to identify these degraded craters. But when you look at our white line and you look at the volunteers' white line, you'll see that we're pretty close. The volunteers' crater seems to be a little bit smaller than ours, but the center is almost identical. This is fabulous. This is phenomenal results.
And the
So it's saying
uncertainty is overlapping. So with the 8 crater, experienced crater people in the field, we had a diameter of 143 plus or minus 16 pixels. Whereas with the volunteers, we had 135 plus or minus 22. So while that's an 8-pixel difference in diameter, because it's so degraded and we're not really sure where the rim is, we have these overlapping uncertainties. So it's not even that, okay, well the volunteers said it was a little smaller, expert says it was a little bigger. It's that we said it was roughly the same within the uncertainties of the markings. And so that's sort of what this paper was exploring, and what it actually ended up showing is that as a whole, overall, when treated as an ensemble, volunteers are just as good as experts in identifying craters. And that means that every single project now is A, going to reference this paper, but B, it means that every single project now can reference this paper and say, look, volunteers do just as well as a group of experts, and therefore all of the results that we're going to talk about should bear out just as well as if, say, I had published a paper based on crater counts I had done, or Irene published a paper based on crater counts she had done, or someone who has 50 years experience in the field were to publish a paper based on crater counts they did. It's going to be just as good as the crater counts that our very dedicated and very time-generous volunteers have done as well.
So this is a real game changer. I'm hoping that it'll wake up our community and say, look, these volunteers are doing phenomenally well when you group them together, and we should not be poo-pooing these results. We should not be poo-pooing their efforts. We should be embracing their efforts, and we should be thanking them profusely for their work because it is valid and valuable.
And you have this situation where, so I said I did 640,000 craters on Mars by hand. It took me 5 years. And that's just craters larger than 1 kilometer, the size of a medium-sized, maybe small city. 1 kilometer sized craters and larger. If you go just to, say, half a kilometer and larger, we're talking about over 2 billion craters on Mars. If you go to a quarter kilometer and larger, and we're still talking about much bigger than an average-sized house. I haven't really been in a house that's bigger than a quarter kilometer. You're talking about maybe 10 billion craters and larger on the Moon or on Mars or on Mercury. And so you're getting to this point where we want to study things at small diameters, say maybe 100 meters across. We want to study these things, but in order to actually do that, you can't. I mean, you cannot rely on a single researcher or a single research group to do it. You have to do this sort of crowdsourcing thing, or you have to have, instead of crowdsourcing, automated computer algorithms try to find craters. Problem is, and this is going to be a future paper, computer codes are worse than we are, and they're worse than volunteers are. And so you have these computer codes that, on their best day, on the train in which they were specifically made to find craters, they can do about 75 to 80% accuracy. On a normal day, on a normal terrain, say pick an average surface on the Moon, they're maybe 60 to 70% accurate, and that's the really good ones. And so this is something that people say, oh, well, computer codes can do it, just stick a computer on it and we'll have 20 billion craters. No.
That's exactly what somebody just asked, actually.
Oh, well, there we go. And I can't see the chat.
Question, if such a method exists, and yeah, that's something you can do in man versus machine in Moon Mappers.
Right, so actually at every Lunar Planetary Science Conference, which is one of the 2 biggest planetary science conferences probably in the world every year, every single year I see another person coming out with a new computer code that's going to be better than the others in order to find craters automatedly. They're still not that great. And as Nicole just said, this is something that we have you guys do in Man versus Machine. Is in Moon Mappers we have these 2 interfaces, Simply Craters, which is just that, Simply Craters, identify craters, and then we have Man versus Machine, where we took one of those computer codes, we ran it for the images that are in Moon Mappers now, and we're having you correct it. So we're seeing a couple things. We're trying to see with this Man versus Machine interface. We're trying to see if it's faster to give you these seed craters, and so it might take half the time to do Man versus Machine than Simply Craters, and we should emphasize Man versus Machine more because you can do more faster. Or it might be that if you're seeing these craters in Man versus Machine that aren't actually craters but the machine said it was, are people more likely to go with the machine and say, yes, okay, I'm going to believe that's a crater, even though I don't really think so, but the machine says it is. And so we get not only this, Irene and I get these data that we can use for our projects, but we're also studying lots of other things with this type of interface. So we're studying a little bit of human psychology. We're going to be studying some stuff with machine learning. So a goal in the future is to actually have maybe a dozen different computer codes running craters that are running these images through their processes and then putting them up and seeing which one is better. Another thing that we found in this paper is this, this really weird tiny offset where people, the volunteers, not the experts, but the volunteers, are more likely to be a little bit more uncertain in the X position of the crater than the Y position of the crater. And we're going, why would that be? And we're thinking, well, it might have to do with it's easier to locate stuff on the screen vertically than horizontally. But these are things that no one's really seen before, but in this interface we can start to learn about. And so we're getting not just lunar science out of this, not just Vestian or not just, what's the other planet? Mercury, or Hermian stuff, but we're also learning a lot of other things from it for other research projects to do. And
so we're going to cut you off for a second.
Okay. We got the 5-minute warning that our Hangout's about to be killed a couple minutes ago. So we're going to have to start a new one. And so what we're going to do is start a new one from my account, same place, and we're going to embed the new YouTube link in all of the same places. In the main event for the Hangout, in the Part 2 event, and then on CosmoQuest.org.
Yes. So stay with us. You will need to refresh your screen, whichever screen you may be on, unless you're on YouTube, in which case you're going to have to go to a new link. To get that new link, go to CosmoQuest.org. And, this might be a good time to take a couple minutes to donate if you haven't already, to share the link out if you haven't already. We're up to 2% of our goal, and we're more than 2% of the way through the Hangout.
Irene and Stuart have given you guys a great overview of the amazing science that this project is doing. So thank you so much, you guys.
Thanks for having us.
Oh, thank you. Yes, you're welcome. It was fun.
Yes, so plug Moon Mappers, Simply Craters, or Man vs. Machine, which I always wanted to rename to Human vs. Machine.
Yeah, no, it's just MVM is a great abbreviation.
Yeah,
so
okay,
that's what
fair
enough.
enough.
But we need to start the next Hangout, so
okay.
Stay tuned, watch the Twitters, we'll share the new link.
Thank you. We'll be back in a minute. Bye. All right. Let's end. It's a webcomic that, geeky and fun that I like. And so not CosmoQuest related at all, but go check out Hijinks and Sue. It's a fun webcomic, and you can get your own little Will Wheaton plushie. And I forgot what the second thing was. I'm sure it'll come to me at some point. So we're monitoring all the Twitters and things. So up next, we do have Stuart and Irene coming from the Moon Mappers team, as long as Tim got my message. Where is he?
So the way things are running today, for those of you who want to see what's going on behind the scenes, or at least hear what's going on behind the scenes, I'm apparently going to mix the word scene here randomly throughout these 32 hours. The two of us are currently running our own production. We will be switching that off throughout the event. This means that our computer, and welcome Stuart Robbins and Irene Antonenko, the co-leads for science for Moon Mappers. So welcome.
Thank you.
Thank you.
Hi. All right, so why don't you just start off introducing yourselves, tell us a little bit about your background, and what are your research goals with Moon Mappers?
Ladies first.
Oh, okay, thank you. Okay, my background, I am a lunar geologist. I've been studying the moon ever since I went to grad school, and I have learned so much about the moon in so many different ways. I'm always amazed when people ask me questions how much I can tell them. It's like, wow, I didn't know I knew that much. So I've been just...
From Astronomy FM, Timothy Legower, my boyfriend who's been roped into this, my proximity, and Ray Sanders, who's one of our CosmoQuest instructors. So.
And so this entire event is really being made possible by the support of not just our significant others who did get roped into things, but also through a bunch of volunteers who are putting a lot of hard hard work into making this weekend possible. And Steve, thank you for the coffee. I'm about to go pour myself another cup. My husband just brought up a fresh pot for us. And I love the fact that he tasted it and felt the need to find a thing of masking tape and put a giant label on the pot, which I'll show you all in a few minutes, that says strong. So apparently the coffee is strong. He then went back down the stairs and brought up creamer. So I'm going to go back to editing the website. Is currently running the show. And Richard Drum is going to be helping out with that in the background for other groups of 4 hours. Every 4 hours, we do have to restart this event. We will continue to embed the link in the main event page on Google+. And then we also have various parts that people have signed up for, and as always, the cosmoquest.org/hangouts page will be playing what's going on. To help get our guests all set to come in, we have a green room hangout set up in the background so that the guests can go in, do a tech check, ask any questions they might have, and the green room is going to be run by a whole variety of people throughout the hangout, volunteers.
Ray, Tim, and Michael.
Yeah.
So those are our green room people. So Michael Forrest.
Completely forgot to put a link to this hangout on cosmoquest.org. So I'm going to fall into happy programmer land here and edit the site live. I should be wearing my shirt that says, I don't always test my code, but when I do, it's in production, because that's what I'm about to do.
Oh, boy.
And we are going to have Stuart and Irene on, if we can get them in from the green room now.
So Timothy in the green room, if you can send Stuart and Irene our way, same link as before. I will also send them. I think I can send them. There they are. There's one. And while I'm doing that, thank you, Richard. Two quick things. One of them is, yes, we have Little Will Wheaton here from Hijinks and Sue.